We'll do one over. I think it's up through 2:4, and then we'll stop and take a little test. It won't be a big deal. Then we'll finish the chapter and take a bigger test at the end. But I want to kind of break it into pieces so you feel like you've mastered basic differentiation rules. Then we'll move into the more advanced differentiation rules, stuff like that, product rule, quotient rule, things like that, chain rule. Okay, there are a couple things though that I want you got to know how to do that'll be very helpful on 2.2. We got to be able to I like to call this pre-writing stuff. So if we have, for example, something like this. Okay, what if I have, we don't have much to go on yet, do we? We've only got one rule, essentially. We just got the power rule, which tells us what? The derivative with respect to x of some constant times x to the n is what? See, what do I do with the n? Bring it down and subtract 1 from the exponent, right? That's one we have. I'll tell you a couple more. I'm not going to prove them to you, but here are the new ones for the day. You can just start using them. We also know that the derivative with respect to x of sine x is cosine x. Okay? And the derivative with respect to x of cosine x equals almost negative sine x. Gotcha. So these are the three that we know, and of course we know the derivative of a constant is zero. Okay. So I guess we could add that one, but that's almost just a preview. These are the three significant derivative rules that we know at this point. How do you do something like this though then? What if I've got y equals like 3 over x? How do I find dy dx? Meaning just the derivative, right?
Because when you because the x is to the negative first
okay.
exponent.
Good. We don't have a rule that looks like that, but we do have a rule that deals with that, right? Everybody agree? So I've got to pre-write this before I even rewrite it, but I call it pre-write because before we do the calculus, we've got to rewrite it. Now this makes sense. I didn't mean to do that. What I meant to do was this. We're going to rewrite the original function. So now I can do the derivative. So what's my derivative going to be?
-3.
Yeah, that comes down, so I get -3x to the
-2.
-2. And if I want to write that in terms of a positive exponent,
-3 over x squared.
yeah, just -3 over x squared, right? Okay, what if I've got something like, how about if we have f of x equals 4/5 x cubed. And I want to calculate the derivative.
You would still do the same steps.
Yeah, that's really no different. I've just got a fraction. So 3 times 4/5 is just 12/5 x squared. No biggie. Okay, what if I have something like this? What if I have y equals the cube root of x, and I want to find y prime?
You rewrite it as x to the 1/3.
Yeah, everybody see that? Just rewrite it as a fractional exponent. And our power rule doesn't just work for integers, it works for all real numbers, it turns out. So then what's my answer going to be?
Wait, you get 1/3 x to the...
To the what? What's our rule say? Yeah, I'm going to subtract 1. 1/3 minus 1 is going to be -2/3, right?
So then that gives you 1/3 times the square root of x squared.
Yeah. Yeah, x to the 2/3 is just the cube root of x squared. We can just write it as a fractional exponent. That's fine. Okay. What if I had, so how would I deal with this one? What if I had something like y equals 1/2 times the square root of x.
First you would have to get the x into x.
Yeah, how would I write that x as a fractional power?
X to the 1/2.
Okay, but if it's x to the 1/2 on the bottom, then it becomes what?
X squared.
Oh, negative, right? A negative power on the bottom is equivalent to positive on the top, and vice versa. So our rule for that would be to say that that a to the n equals 1 over a to the minus n, or 1 over a to the positive n equals a to the minus n. Right? So in other words, if we flip the position of the power from top to bottom or vice versa, that just always involves changing the sign of the exponent. Okay, so this I could rewrite as 1/2 x to the negative 1/2. Now we just fire away with the power rule. Right, so what's y prime gonna equal?
Negative x to the negative 3/2.
Yeah, negative 1/2 minus another one is negative 3/2. Yep. Okay. What about, so what did we say about differentiating a sum of terms?
You take them individually.
Yeah, we can differentiate term by term, which is very good, right? That makes life easy. So derivative of the first term is, what's the derivative of x with respect to x?
0. I mean, no, it's 1.
1, right? Derivative of x is 1. Why?
Because the
True.
exponent's 1,
Mhm.
and so you put that on front, and then that 1 minus 1 is 0, and anything from 0 is 1. So you
Okay, so it is consistent with the power rule, but we always just know too, there's a couple ways we could look at this. If y equals x, then dy dx would be the same thing as I'm taking the derivative of both sides with respect to x. There's another notational way of looking at that. So that's going to be the derivative with respect to x of x. Well, dx is 1, algebraically. There's another way to look at it. You could look at it as, you could think of it as a slope. This is a line with a slope of 1, right? And so the derivative is 1. There's a bunch of different ways you can look at it. But I guess we just probably need to almost add that to our list. The derivative of x is 1, right? That's enough that we don't have to go through all this hassle. We just know it's 1. So that gives us 1. What's the derivative of cosine x? Remember?
Negative sine x.
Yeah, so that's going to end up giving us that for our derivative. Okay, no big deal.
So the derivative of a negative cosine x would be positive sine x?
The derivative of a negative sine x, say it again,
Negative cosine x would be positive sine x.
Yeah, well, I mean, all we're doing is we're just subtracting, really what it is, I just subtracted negative sine x. Okay. All right, how about, I'm not gonna do a bunch of rates and change stuff, but I wanna do a good thing. What if we had something like this? Okay. I want to know I want you to find equations of lines tangent to
Oh, is this a definition of parallel ones?
yeah. Let's do a couple of those. Tangent to, how about y equals 1 over cube root of x squared at x equals 8. Okay. So how am I going to do that?
Start by just, they start by.
Okay, I mean, I'm gonna need the derivative. What are the pieces that I need to build one?
Slope.
Slope and,
B.
well, or just a point, right? I need a point and a slope to find the line. Point is not calculus stuff. How do we find the point?
You just put 8 into the equation.
Okay, so if I plug that into the equation, I've got I could either say 8, the cube root of 8 squared, or I could say the cube root of 8 quantity squared, or the cube root of 8 squared. I think it's easier to do the cube root of 8, which is 2 squared. What is that? 4, everybody agree? Okay, so I'm gonna get 1/4, right? So we get 0.814. That was easy. But now we need the slope of the tangent line. Where's that come from?
You do the y.
I need the derivative, don't I? Right? So y prime is, well, before we can even do y prime, maybe we need to rewrite this. How do we rewrite y in a way that's gonna allow us to take a derivative? What do you think?
1 over x to the 2
Okay, so it's 1 over, so the cube root of x squared, right? The 2 is the numerator and the 3 must be the denominator, right? Because it's cube root is a 1/3 power. So we have x to the 2/3, negative 2/3. Okay, so then that means that y prime is, what am I gonna do? Okay, I gotta bring the exponent down front times x to the, what's negative 2/3 minus 1? Negative 5/3. Okay, so we need to know, to find out what the slope of the tangent line is, what are we gonna do with that derivative? Yeah, we gotta evaluate it at x equals 8, right? Okay, so then we end up with, at x equals 8, y prime equals negative 2/3 times x to the minus 5/3 is just 1 over x to the 5/3. So 8 to the 5/3. How are we gonna do 8 to the 5/3? What are you gonna do? What are you gonna do, calculator? Oh, we don't need a calculator. What does 8 to the 5/3 mean? Cube root of 8 to the 5th. So what's cube root of 8?
2.
2 to the 5th? 32. Yeah.
Yeah, good job.
Okay. So we're gonna get negative 2/3 times 1 over 32. So let's see, that makes that a 16. So what, negative 148? So there's our slope. There's our point. Now it's just algebra 1, really, right? We just gotta find the equation of that line. So how do we do that? A bunch of ways. You guys probably were trained to just, you know M, so solve for B. Is that right? Yeah, I think that's a good way to do it. So then we know y equals negative 1/48 x plus b. Let's plug in the value. X is 8 and y is 1/4. So what is that, 1/6? Negative 1/6. So if I add 1/6 to both sides, b equals 1/4 plus 1/6, right? So what is that? 3 equals 5/12.
Yeah.
Is that right? So what's our equation then?
Y equals negative 1/48.
That's m, x plus divided by 2, there you go. Okay, make sense? Okay? I think you're probably pretty good. I think we're good to go. We got time?
Yep,
Okay.
20 minutes.
20 minutes?
No, we've got 10 minutes.
No, we have 20 minutes.
Oh, jeez, let's talk.
Okay, should we just go to 2:05?